In section 1.4, 7th graders, we are going to talk about solving equations with absolute value in them. So we're going to talk about solving absolute value equations. So what are you going to learn? Well, you're going to learn how to solve absolute value equations, how to solve equations involving two absolute values, and then also identify what's going to happen when sometimes you get a special solution. So let's first start talking about solving just basic absolute value equations. An absolute value equation is an equation that contains an absolute value expression. You can solve these types of equations by solving two related linear equations. So I'm going to start with just a basic example. If I told you the absolute value of x was equal to 4, what two values of x would make that equation true? The absolute value of what gives you 4? Well, it could give you 4, or it could give you negative 4. Notice that I can solve this by writing two related linear equations. The same thing is true if I do something like this. X plus 1 in absolute value equals 4. Well, I know that this right here, the x plus 1, this whole thing has to be either 4 or negative 4. So the expression x plus 1 has to equal 4 or negative 4. Notice that I wrote two separate equations. That's the process that you're going to take to solve absolute value equations. Here is your core concept. Here it is. All right, properties of absolute value. These are just the properties of absolute value. Number one, this is probably the biggest one that people forget. Absolute value has to be equal to 0 or greater than 0. This number right here has to be greater than or equal to 0 when the absolute value is isolated by itself. We know that the absolute value of a negative a is equal to an absolute value of a positive a. We can separate it in that the absolute value of ab is equal to the absolute value of a multiplied by the absolute value of b, and we can also do the same for division. The absolute value of a divided by b is the same as the absolute value of a divided by the absolute value of b. Now to solve an equation, we just explained this. If you have, now remember, the absolute value has to be isolated. If it's equal to c, and c is greater than 0, then we could say ax plus b is equal to c, and ax plus b equals negative c. Now, when c is less than 0, that means this value right here is less than 0, we have no solution, because absolute value always indicates a number that is not negative. You cannot have an absolute value, a value of that to be negative. Therefore, if it's negative, your answer is no solution. So example 1, let's solve both of these. We want to solve each equation and graph the solutions if possible. So in the first one, ask yourself this question. Is the absolute value isolated? Yes, this entire thing is by itself. So I'm going to write two separate equations. X minus 4 equals 6, and x minus 4 has to equal negative 6. I now solve both of these, so I use the addition property. I add 4 to both sides. That gives me x equals 10. And I add 4 to both sides. And that gives me negative 2. So the solutions are 10 and negative 2. So if I graph that, I put a dot on negative 2 because that represents a solution. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I put a dot and that represents the solution. And there's my answer. Now in part B, I have the absolute value all by itself, but then I have a negative. That does not work. The absolute value cannot be a negative if the absolute value is by itself. which it is. So therefore, this has no solution. In example 2, we're going to solve this equation. Now in this example, you will notice that the absolute value is not by itself. So we have to make it by itself. Step 1, we are going to add 10 to the other side by using the addition property of equality. So that's going to give us 3 multiplied by the absolute value of x plus 3 equals 6. I do not distribute the 3. I divide both sides by 3 by using the division property of equality. That gives me the absolute value of x plus 3 equals 2. From there, I can write my two related linear equations, which are x plus 3 equals positive 2 and x plus 3 equals negative 2. If I solve those, I get x equals negative 1 by subtracting 3 on both sides. And if I subtract 3 on both sides, I get x equals negative 5. So my two answers are 1 and negative 5. Now in example number 3, we're writing an absolute value equation from a word problem. It says that in a cheerleading competition, the minimum length of a routine is 4 minutes. The maximum length of a routine is 5 minutes. Write an absolute value equation that represents the maximum and minimum lengths. So here's how you're going to start this. If you model this using a number line, it's going to be a lot easier. So let's start with this. Now you can think of this in your head. You don't actually need to write this down when you do your homework. But here, the minimum is 4 minutes, the maximum is 5. Halfway is right here. Your halfway point would be 4.5. And this is where your absolute value comes into play. The distance from 4.5 to 5 is a half. The distance from 4.5 to 4 is also a half. It's the same on both sides, and that's how you set this up. If I subtract the half on both sides of the halfway point, so x minus 4.5, that difference has to be equal to half. It's a half this way, it's a half this way. So the halfway point goes here, the distance from the halfway point goes here. So you're going to have the absolute value of x minus the halfway point equals the distance from the halfway point. Now, solve this on your own. If you solve that, you get this, which if you look, we know that the minimum and maximum lengths would be 4 and 5 minutes. So we just wrote an absolute value equation that proves our problem. Now, when you solve equations with two absolute values, they must be either equal to each other or opposites of each other. So let's look at it this way. What it means by two absolute values is that you have an expression that's an absolute value and another expression with an absolute value. Make sure that they are equal to each other or opposites. So here's equal. They're equal to each other, or they are opposites of each other. So they're equal to, you just take ax plus b equals cx plus d, or ax plus b equals the opposite of cx plus d. So let's start with the a. The absolute value of 3x minus 4 equals the absolute value of x. So we're going to write it equal to each other. So 3x minus 4 equals x. Or the other answer is going to be 3x minus 4 equals the opposite of x. So now we just solve both of these. So I'm going to subtract x, 2x minus 4 equals 0. I add 4 to both sides. I divide by 2. I get x equals 2. Now here, if I add x, that gives me 4x minus 4 equals 0. I add 4, divide by 4, I get x equals 1. So my two answers are x equals 2 and x equals 1. Now in example B, I'm going to do the same thing. Actually, do this yourself. No, don't do this yourself. We're going to start with the first one. 4x minus 10 equals 2 multiplied by, oops, that should be a parenthesis. So let me change that to a parenthesis. 2 multiplied by 3x plus 1. Now the other one, though, is going to be 4x minus 10 equals... Now notice the 2's on the outside. That does not change. But what does change is I have to take the opposite of the absolute value, which is 3x plus 1. So you can solve the first one. Actually, I'm going to pause the video. We're going to solve both of these. You should be able to solve both of these on your own. Now, if you solve both of these, I distribute, you will eventually get x equals negative 6 as an answer. And the other answer, I distribute the negative. Then I distribute the 2. I'll get 8/10 or 4/5. All right, so now let's start off with a really fun word. Repeat after me, extraneous. There you go. Say it one more time. Extraneous. So here's what it means. When you solve an absolute value equation, it's going to be possible that a solution is going to be extraneous. An extraneous solution, vocab word, is an apparent solution that must be rejected because it does not satisfy the original equation. Basically, what you're going to have to do is you're going to take your answer and you're going to plug it into the original equation. If it doesn't work, it's an extraneous solution. So let's try this out. Bam, here we go. So we have the absolute value of 2x plus 12 equals 4x. The absolute value is by itself. So therefore I can write what two equations? 2x plus 12 equals 4x, or 2x plus 12 equals negative 4x. So if we solve these, I'm just going to subtract 2x. That gives me 12 equals 2x. Divide by 2, x equals 6. All right, so x equals 6. And then we add 4x. That gives me 6x. I subtract the 12, equals negative 12. Divide by 6, I get x equals negative 2. Sounds easy enough. It sounds like those are your answers, but now we got to plug them in and check them. So here we go. Let's plug in the 6. You can do this in your head. So let's see. 2 multiplied by 6 is 12. 12 plus 12 is 24. The absolute value of 24 is 24. Equals 4 times 6, which is 24. Bam, that checks out. X equals 6 is an answer. Go to the next one. Let's plug in negative 2. 2 multiplied by negative 2 is negative 4. Plus 12 is 8. Negative 2 times 4 is negative 8. That does not work. Therefore, x equals negative 2 is not your answer. Therefore, 6 is the only answer. Because negative 2 is an extraneous solution. All right, we're solving our last problem. What are the two equations that you would write from this? Tell me what you'd write down. X plus 5 equals x plus 11, okay? Or what's the other one? X plus 5 equals negative times the quantity x plus 11. So let's solve both of these. Subtract x, that gives me 5 equals 11. Nope, that doesn't work. False statement. So now if we solve this one, x plus 5 equals negative x minus 11. If I add x, 2x plus 5 equals negative 11. If I subtract 5, that gives me negative 16. X equals negative 8. Now plug it in. Negative 8 plus 5 is negative 3. The absolute value of that is positive 3. Negative 8 plus 11 is 3. The absolute value of that is 3. That works. X equals negative 8 is your only answer.